Alright, now we're going to do more practice. Polynomial, long, and synthetic division. Okay, if x equals 2/3 is a 0. Find all of the remaining zeros. If f of x equals 48x cubed minus 80x squared plus 41x minus 6. Go. Okay, so keep in mind, again, if x equals 2/3 is a 0, and you do synthetic division, which is what I'd recommend, then what should you expect as the remainder? So I want you to try to find all of the remaining zeros given x equals 2/3 is a 0. My hint is that start with synthetic division. X equals 2/3 is what you will put in the corner. Alright, so we should get x equals 1/4 and x equals 3/4 are the remaining zeros. Again, answer the question. What was the question asking us? The question was saying, what are the remaining zeros? We already know 2/3 is a 0. So since it asked for the remaining zeros, we do not need to list 2/3 again. Had it been like the problem we did last night, or the previous night, then we would, where it's saying list all of the zeros, even if it's giving you one to start with. Okay. So, how did we come about that? Well, I did synthetic division. So I put 2/3 in the corner, 48, negative 80, 41, negative 6. Add vertically, multiply diagonally. 2/3 times 48 is 32, negative 80 plus 32 is negative 48, times 2/3 is negative 32, 41 plus negative 32 is 9, times 2/3 is 6, 6 plus negative 6 is 0. Good thing I got 0 as a remainder, so therefore I did not mess up, and I was not lied to. Now, write my quotient function, so q of x equals 48x squared minus 48x plus 9. Set that equal to 0 to find the zeros. I combined a step here. I also divided this entire thing by 3. I can do that because I'm solving. So this became 16x squared minus 16x plus 3. That makes it easier to factor. So this factors into 4x minus 1 times 4x minus 3. Set each factor equal to 0. And I get my remaining zeros. Okay, divide 2x cubed minus 4x squared minus 15x plus 5 by x squared minus 2x plus 1. Pause the video, do your division, unpause when you are ready to check your work. Okay, so here we need to do long division. So I set on my long division, here's my divisor, here's my dividend. I get a quotient of 2x and a remainder of negative 17x plus 5. So I write plus negative 17x plus 5 over x squared minus 2x plus 1. Just to go through the work, 2x cubed divided by x squared is 2x. 2x times x squared is 2x cubed. 2x times negative 2x is negative 4x squared. 2x times 1 is 2x. Now I subtract. This becomes 0. This also becomes 0. This becomes negative 17x. And I bring down the 5. Negative 17x does not divide by x squared, so that is my remainder. Next one. Use synthetic division to find all of the factors of f of x equals x cubed plus 2x squared minus 3x plus minus 6, given that x minus root 3 is a factor. So again, what does that mean? That means that if I do synthetic division, I should get a remainder of 0, otherwise I messed up, or I was lied to. So, I want you to try this on your own, pause first, then unpause when you're ready to check your work. Okay, so we should end up with x minus root 3, x plus root 3, and x plus 2 are all of the factors of f of x. Now, this format right here, this is what we call a product of linear factors or linear factored form. Okay, how did I come up with that? Well, I said to use synthetic division. So I took x minus root 3, set it equal to 0, I got x equals root 3, that goes in the corner. Took my coefficients, 1, 2, negative 3, negative 6, set those up. Add vertically, multiply. 2 plus root 3 is just that, 2 plus root 3. I cannot combine those. Root 3 times 2 plus root 3 becomes 2 root 3. I'm sorry, root 3 times 2 is 2 root 3. Root 3 times root 3 is just 3. So now I add, negative 3 plus 3 cancels, and I'm left with just 2 root 3. Root 3 times 2 root 3 is 6. Negative 6 plus 6 is 0. So good. I was not lied to, and I did things correct. I got 0 as a remainder. My quotient, q of x equals x squared plus the quantity 2 plus root 3x plus 2 root 3. And then you're looking at this, and you're like, wait a second, Mr. Rumpf, Ms. Schwartz, how the heck am I supposed to factor this? What do I do from here? I don't like this. I'm done. I give up. I quit. I'm going home. Wait, I'm already at home because I'm watching this on my computer. This sucks. But what you realize then a second later is, oh, this is still just factoring. What multiplies to 2 root 3 and adds to 2 plus root 3? It has to be 2 and root 3. Oh, yeah, that ain't bad. So q of x factors into x plus root 3 and x plus 2, and I take my original factor of x minus root 3, and I can write all of the factors. Now, another thing to point out about this problem. I asked you, or told you, to do it using synthetic division. Could you have done this a different way? Yes, that was a loaded question. So we could have also, if I just said find all of the factors, you could factor this by grouping. So if I bring this over here, I can say f of x equals x squared times x plus 2. Factor out a minus 3 times x plus 2. So now f of x equals x squared minus 3 times x plus 2. And the x squared minus 3, that's what gives me x plus root 3 and x minus root 3, and then I still have the x plus 2. So, just want to point out that there are other ways to do the problem. I just told you a specific way to do it though. Okay, next one. Given x plus 3 is a factor of the function, write the function as a product of linear factors. So I just told you what that meant on the previous problem. Product of linear factors. These are all linear. What makes them linear? They are first degree polynomials. So again, if I look at this right here, f of x equals x squared minus 3 times the quantity x plus 2, this is a product of factors. This right here is not a linear factor because it is x squared. So, go ahead and do this. There are a couple of ways you can go about it. I'll let you choose what you want. Pause the video, unpause when you're ready to check your work. Alright, so I should end up with f of x equals x plus 4 root 3 times x minus 4 root 3 times x plus 3. And I did this in two different ways. So it was up to you on which one you chose to do. First method I chose was just factoring by grouping. I noticed that 48 is a factor of 144, and if I factor out 48 from 144, I get 3. So I can see that this factors by grouping. So I group the first two, group the second two, make sure to put the negative in there on that third term. Factor out an x squared from the first two, factor out a negative 48 from the second two. I'm left with x plus 3, so I know I've done this correctly. And then I get x squared minus 48 and x plus 3. Now, if you're comfortable and you understand how to factor x squared minus 48, you can go right to your answer of x plus 4 root 3 and x minus 4 root 3. If you're not, or if this didn't factor nicely, what you can do is set it equal to 0 on its own and solve. So I added 48, took the square root and simplified, and then now rewrite those solutions or zeros as factors. So I know if x equals plus or minus 4 root 3, then the factors were x minus 4 root 3 and x plus 4 root 3. So this is my answer. That's a product of linear factors. Another way to do the problem is synthetic division. So if I take the given factor, x plus 3, also notice that showed up in my answer, which is a good thing. Set it equal to 0 and solve. I get x equals negative 3. Use my coefficients, 1, 3, negative 48, negative 144. Do synthetic division, bring down the 1, multiply, add, multiply, add, multiply, add. Got a remainder of 0. That's also a good thing. And my quotient is x squared minus 48. So now I have to do exactly what I did up here, and I have to actually either understand how to factor that or solve it, set it equal to 0 and solve, and then I would rewrite it as factors. Next one, express the function in the form f of x equals x minus k times, this is supposed to be a q, I apologize, q of x plus r, and demonstrate that f of k is r. What does that mean? Alright, simple thing, start out, do synthetic division. This is your k, so that goes in the corner. Go ahead and put that in the corner, do the synthetic division. Try to write the answer in this form if you can. If you don't understand it, then unpause the video and listen to what I have to say. So pause now, do the synthetic division though. You can at least do that. Okay, so the initial answer is to write f of x equals x minus 1/5 times the quantity x squared minus 20x minus 7 plus 13/5. How do I come up with that? Well, I did synthetic division, so I put 1/5 in the corner, 10, negative 22, negative 3, 4. Bring down the 10, 1/5 times 10 is 2, add, I get negative 20. 1/5 times negative 20 is negative 4, add, I get negative 7. 1/5 times negative 7 is negative 7/5. That's not that nice, right? So 4 plus negative 7/5. Well, you can see off to the side here, I made a note to myself, 4 is the same as 20/5. So 20 plus negative 7 is positive 13/5. So this is my remainder, which is fine. Remember, I didn't say that 1/5 is a 0, so I didn't have to get 0 as a remainder for this problem. So now I'm just trying to write f of x in this pattern. So x minus k is x minus 1/5, because this was a positive 1/5. Q of x is the quotient, so that's times, it's times q of x, so times x squared minus 20x minus 7, and then plus r is the remainder. So the point of this notation is, this is what we call the division algorithm. This was also in your notes. But if I was to multiply this out and add 13/5, I would get right back to this original form of the function. Now, the second part said, verify that f of k equals r. So I used my calculator for this. And on the calculator, I actually typed in 10 times 1/5 cubed minus 22 times 1/5 squared, and so on. Hit enter, I get 2.6, math fraction, that is 13/5. So yes, f of k does equal r. Verified. Okay, that was good practice. So a linear factor is a first degree binomial or a first degree polynomial. It does not have to be binomial, I should say. And we know f of k equals r when we do synthetic division.